Hello, everyone. I'm Mr. Baker, and we're going to continue in my environmental science class talking about water because it's really important, right? So, we're going to look at a few different questions today. We're going to look at how water is being used globally, how fresh water is managed to extend its use, because remember, it is one of those limited resources that we have, and what kinds of water pollution are occurring and how can it be managed. That's just kind of a bumper question because we're talking about how fresh water is managed, so let's talk about why it needs to be managed. Right. So residential and industrial and agricultural are our three big global water use uh, reasons. So residential is used inside the home. That includes like watering your plants, washing your car, washing dishes, flushing toilets, laundry, brushing your teeth, taking a shower, all that stuff is residential. About 13% of fresh water is used for this purpose all over. And we have water treatment plants to kind of extend the life of that water. We're going to talk about that in a little bit. Industrial use, however, is making stuff from the cell phones in your pockets, the computer devices that we have, to paper products. All that stuff is industrial. Plastics are a big one as well. So about 20% of our fresh water gets used for that, and that water sometimes gets locked into those products. Like, you can't get the water back out of this computer mouse without melting it down and completely taking it back to its constituent atoms. But it is through this production or the production of energy that we're talking about with industrial, right? Agricultural, growing food, feeding animals. About 67% of our water goes to this. So this is a big source of water use. And a lot of it goes towards irrigation. Irrigation is to water plants, right? And we're going to talk about how that in and of itself becomes a big thing because it is the largest use of water. So moving water around is important. There are four main ways that we do that. Aqueducts are big channels that are used to move water from one location to another. They are a very ancient technology dating to pre-Rome, right? Canals are the same thing, but in the ground, right? We can move the water different places and we can use that water to move products as well. Dams like the one shown below my face are used to store up water or to use that water to create energy, sometimes both. Behind a dam is a reservoir. So the picture below is from the opposite side of the dam as the reservoir. The reservoir would be on the other side of this big wall, hopefully way up here, nice and high, because that means there's a lot of water to be used. And as the water goes through the dam, it can be moved from the reservoir to the downstream side and produce electricity along the way. One of the ways that agriculture is starting to use water more efficiently is through smarter irrigation. This includes a lot of technology in it, right? So we have a smarter irrigation system that is watering specifically where the plants are instead of just watering every place. There are a bunch of sensors in the air and in the ground to only deliver enough water that's necessary to grow it so that we're not over-watering. And there may be a large technological backbone to this. AI, server space, and larger cloud systems as well that can allow farmers to save money in how much water they use, as well as to serve the environmental resource projects that are going on. This is part of a proponent of agriculture that's moving towards a more sustainable and a easier way of doing things while continuing to make a profit. Right? Another way that we can talk about this is personal water conservation. So things as easy as not letting the water run while you're brushing your teeth, or using a high efficiency dishwasher, or doing your dishes yourself. High efficiency laundry services, so high efficiency washing machines, high efficiency hot water tanks, all are better suited towards not using as much water. You could have a low flow toilet, or, there is a larger proponent of not flushing the toilet all the time when you go to the bathroom. I'll let you make that decision on your own, but it is a thing that's out there. Xeriscaping is the idea of using your landscape around you, the smaller bit, right, like your lawn here in the US, to be not as reliant on water. And we can also do this through using more conventional or, sorry, had to cough, a plant that is indigenous to the area, right? So a plant that is actually supposed to live in the area that you live in, as opposed to what we see a lot of places in the US, at least, these luscious green lawns full of grasses. Grass takes a lot of water, and it requires a lot of maintenance, whereas xeriscaping focuses on lower maintenance plants and actually treating our lawns like small pieces of nature. We also have desalination plants that focus on removing salt from water to create fresh water from salt water. This is an expensive procedure. It requires a lot of energy, it requires a lot of input, and it requires large space to actually do it. Below me is actually only one part of a large desalination plant that is on the west coast of the U.S. Right? The other way that we do this is by treating our sewage. Sewage, of course, is the water that leaves residential or industrial property after it has been used. And there are two different phases. There's primary treatment and secondary treatment. Primary treatment is mainly removing solids from the water itself. Secondary is using chemicals or using biotic factors like bacteria and algae to clean the liquid part of the water so that it's back to fresh water that is potable. You can drink it. Sometimes this requires a third step called tertiary treatment. Doesn't always require it, all right? So by the end of it, it is ready to come back out of your faucet or your shower head or whatever you're using your water for inside your house. While the, let's say, non-desirable parts of the sewage get disposed of and moved to another area, a lot of times it can be used for fertilizer. Right. So all of this happens because we want to make sure our water is as clean as possible and we can use it as long as possible. But sometimes bad things happen, right? We know the world we live in. So we've got two different types of pollution that can occur. And these are more of categories, right? We have point source pollution and non-point source pollution. They are obviously opposites. Point source, we know that it's limited to one specific thing. It is this exact little thing or source, if you will, one way that pollution is entering our system. Whether that's a stream, a lake, a river, an ocean, doesn't matter. Non-point source is much more widespread. All right, we're going to go more in depth on that in one of the assignments this week. All right? Wastewater and runoff can become pollutants. So if your wastewater isn't being treated correctly, or if, I'm going to go back a slide, this grit disposable or the sludge treatment or this stuff gets put into a natural waterway, that would be a pollutant, right? Runoff here is talking about like water that, say, hits pavement or is melted snow sometimes, and it's going to take any pollutants that were once on something, and as it moves off of wherever it is, it's going to bring those pollutants with them. Agriculturally speaking, this could also be extra water that's coming off of the field that has chemical fertilizers or pesticides or insecticides in it. And as that moves off of the farmland, it could hit a watershed. And that would be runoff, right? We already talked about sewage. Thermal pollutants are a little bit rarer, but it's when a body of water is negatively impacted by the dumping of something into it because it makes that water hotter or colder than it's supposed to be. So this is more of a secondary thing that happens when other pollution is happening. Sometimes it's okay to dump things into water sources, right? We have nuclear power plants that use water as a coolant. It's just a coolant. Nothing bad enters it. Radiation doesn't enter it. No chemicals enter it. It just gets hotter. But when you reintroduce that water back into the ocean, it heats up the ocean around you. This is a bigger problem in Asia and Japan especially, where they have nuclear power plants that do this. I know of a few instances in Japan where this has happened, and they've actually had to create man-made ponds for this water that's used for cooling nuclear substations and nuclear power plants. Groundwater pollution is when we hit that aquifer with pollutants, right? And it's not really on purpose. It's just something that happens. So instead of going into a watershed, it's hitting an aquifer, right? And that's what we call groundwater pollution because it's water that's in the ground, right? It's in the name, much like a lot of science stuff. Right, so we talked about how water is being used globally. We talked about those 3 percentages. For my class, make sure you know those 3 percentages. Usually I don't make you memorize numbers. This is one of those times. We talked about how we treat fresh water and we manage it to extend its usefulness. And we talked about some pollutions. Right, as always, continue asking questions and keep learning.